Hello, fourth grade. It's Miss Wilson again here with another math lesson. I want you to know I miss you so much. I went up to the school today to get resources that I can use for this virtual learning, for this learning online, and the classroom was not the same without you. It was quiet, and you know we don't do quiet. So I definitely missed the jokes. I missed the laughter. I missed the hugs at the door. So please know that I am missing you and we're going to get through this together. So, like I said the last video, we're going to start each video out with um, some type of sprint or some type of review from Zern. So that's what we're going to start it out with. And it's called Discovery Canyon. So let's see what this is about. All right, so I have 277 plus 469, and they want me to show that using a place value. So first I'm going to start with 277. So in my hundreds place value, let's start with the ones. In my ones place value, I have 7 ones. In my tens place value, how many tens do I have? Yes, 7. So I'm going to put 7 tens. 5, 6, 7. And then I go to my hundreds place value. And how many hundreds do I have? 2. Good job. Now they're going to want me to add 469. So again, I'm going to start without my ones place because I always add my ones first. And so I have 9 ones. 2, 3, 4, 5, 6, 7, 8, 9. I have 6 tens. And I have 400s. Okay, so I'm gonna count my numbers together, and they want me to start with the hundreds. So I have 2, 4, 6 hundreds, 2, 4, 5, 10, 11, 12, 13 tens, and I have 2, 4, 5, 5, 10, 12, 14, 16 ones. So now we need to bundle. And in my bundles, I start with the 1, and in each bundle I need to have 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to take these 10 and bundle those into a 10. Then I'm going to count how many ones I have left. 1, 2, 3, 4, 5, 6. I don't have enough to bundle into a 10. Now I'm going to go to my tens place and see if I have 10 to bundle into 100. 5, 6, 7, 8, 9, 10. So I'm going to take those 10 tens and bundle it into 100. And that's going to leave me 4 tens. I don't have enough to make another bundle of 10. All right, so now I'm going to count them again. 2, 4, 6. So I have 7 hundreds, 4 tens, and 6 ones. All right, and so now I'm going to record my answer in the algorithm. So 7 plus 6, 7 plus 9 is 16. Put my 6, see how I carried my 1? And then 7 plus 6 is, yes, 13 plus my 1, 14. And again, I'm going to carry my 1. So I have 2 plus 4, 6 plus 1, 7. So whether I'm using my place value or my algorithm, they come out the same. We, all right, good job. That's that was funny. Good job. That's our um Zern or our warm up for the day. So we're definitely happy for that. So next, we're going to go to our lesson for today. And then for our lesson today, we're actually going to have a visitor help us today. And he's going to do prime numbers. So our lesson for today is I can identify prime numbers and I can identify the visibility of prime numbers. So during this video, he's going to be talking to us, but I'm also going to be chiming in and giving my little feedbacks on the things we've learned and things that is new to us and vocabulary, of course.
Math lesson, you found a lesson on prime numbers. Before we talk about prime numbers, let's first talk about factors. Factors of a number are two or more integers where their product is the number. Two or more integers where their product is the number. So this is best illustrated by the number 10.
Okay, so before we get into the number 10, I want to go over that new vocabulary word, integers. So integers is just a 6th grade, 7th grade word for number. Okay, it's two numbers that are multiplied to get their product.
We've got the number 10, and what are the factors of 10? Well, we all know that factors of 10 are 2 and 5, right? So 2 and 5 are factors of the 10, or two or more numbers where their product, meaning if you multiply them together, you get back to the number. 2 times 5 is 10. All right, how about a question like this? B, is 3 a factor of 108? Is 3 a factor of 108? Well, you can figure out if any number is a factor of another number by simply dividing them and making sure that it divides into it evenly.
Okay, and we know when we say does it divide evenly, it does not have a remainder. And remainder means there's portions that are left. So when you're dividing to see if a number is a factor of another number, you need to ensure that it divides into it equally. There is a 0 remainder.
So the question is 3 a factor of 108? Take the 3 and divide it into the 108. If it divides in evenly, it is a factor. Now there's the divisibility rule for 3. We'll talk about that in a moment. But this will care for any integer. So 3 goes into 10 3 times. 3 times 3 is 9. All right, 18, and 3 goes into 18 6 times. And sure enough, 3 divides evenly into 108. And so, yes, indeed, it is a factor. Okay? It is a factor. C, there can be more than 2 factors. So keep that in mind. Sometimes students get locked in to think that there's only 2 factors for any given number. Well, there can be more than 2. And so a simple example here is the number 12. And if we wanted to, we could factor 12 into a 2 times a 2 times a 3.
Okay, so right here, I know you're thinking, Ms. Wilson. So the factors of 12 is 1 and 12, because 1 times 12 is 12, and also 4 times 3, because 4 times 3 is 12. So this is saying 4 times 3 is 12. So when you factor, you take all numbers down into prime numbers. 4 is not a prime number because 4 has 4 factors. It has 1 and 4, and then it has 2 times 2, 2 and 2. So they factor 4 down to 2 and 2, which still equal the same because 2 times 2 is 4, 4 times 3 is 12.
Right? 2 times 2 times 3. Because 2 times 2 is 4, times 3 is 12. All right? So factors, there can be more than 2. Okay, let's get into our divisibility rules. All right? Divisibility rules. So number 2, divisibility rules. Divisibility rules are an aid to finding factors. All right, so if you'll keep this in mind, it'll just make it easier to factor numbers. And factoring happens all the time in math. All right, so 2. It's easy to understand if a number is divisible by 2 because if the number's even, then it's divisible by 2. How do you recognize an even number? It ends in 0, 2, 4, 6, or 8. You've learned that probably these days since kindergarten.
And when he says and then, he means that in the ones place value, you're going to have 0, 2, 4, 6, or 8.
All right, so we won't belabor that point. How about 5? How about 5? There are 2 conditions, right? If the number ends in what or what? All right, you're thinking now?
Yeah.
All right, hopefully you're thinking 0 or 5, right? The number ends in 0 or 5, we know it's divisible by 5. It's simplistic. Number 10 is divisible by 5. 80 is divisible by 5. 75 is divisible by 5. It ends in a 0, ends in a 5. It's divisible.
And that's what made, when we were in kindergarten, that's what made counting by 5 so easy for us. Because as we were counting, we knew that in the ones place, there would be a 0 or a 5. 5, 10, 15, 20, 25. All those means that I can divide 5 into them evenly with no remainder.
By 5. All right, 10, it's got to end in, and hopefully you know 0, right? 10 is important. We'll use that in our factoring, and it comes up a lot. Now, how about something like 4? How about something like 4? Do you remember the divisibility rule for 4? Well, it goes like this. A number is divisible by 4 if the last, do you know what fills in the blank?
2.
All right, hopefully you're thinking 2. If the last 2 digits are evenly divisible by 4. What do I mean by that? Let's take a look at this number right here. So is 7,172 divisible by 4? So what I want to do is I want to take the last 2 digits, 72, and I want to ask, is 72 evenly divisible?
And remember, when we learned about fractions, we said when we get to 5th grade, the fraction bar is going to mean what? What operation is the fraction bar going to mean when we're in 5th grade? Correct. It's going to mean division. So when he says this fraction of 72 over 4, that's actually saying 72 divided by 4.
Divisible by 4, and 4 goes into 72 18 times. So that's a yes. That is a yes. And so 7,172 is divisible by 4. Now, I'm showing you this second example on purpose. I'm going to take my red here because the number ends in 00. And some might say, well, that, 0 is not evenly divisible by 4. Well, yeah, 0 divided by 4 is 0. But it's really an exception because this number is in the hundreds, a multiple of 100. 100, 200, 300, 400, in this case 700. And you can divide any 100 by 4, right? 100 divided by 4 is 25. So this is a yes, and that's an exception. And I wanted to remind you of that exception. So if the number ends in 00, then indeed it is divisible by.
Okay, so let me go over that one more time for you, just in case he was moving fast. So 4 is 100 is divisible by 4 because 4 times 25 is 100. So that means any of the hundreds, as long as it's an even 100, 100, 200, 300, 400, 500, they will all be divisible by 4. So if I have 200 and I decompose them, which means to break apart in math, I decompose them and I have 100 and 100. I can divide 100 by 4 and get 25. I can divide the other 100 by 4 and get 25. 25 plus 25 is 50. So 200 divided by 4 is 50. And it'll go on with 300, 400, 500, 600. So knowing the disability rule is not telling you what the answer is. It's helping you to not have to divide every problem by every number to see if it's divisible. You can look at them and see if, now it doesn't tell you what the two factors are, but it at least tells you one of the factors, and then you can divide.
4. All right, so what have we talked about so far? What are factors? Two or more integers where the product is the number. How can you tell if a number is a factor? Divide it into it. If it divides it evenly, it is a factor. And then we have our divisibility rules for 2, for 5, for 10, and for 4. All right, let's get to 3. A number is divisible by 3 if the what of the digits? And I hope you're thinking the word sum. Remember that divisibility rule? If the sum of the digits are evenly divisible.
Okay, so let's go over the definition of sum. Sum is the answer that you get when you add numbers. Okay, so just in case we have forgot the vocabulary sum, it is the answer that you receive after you add numbers.
Divisible by 3. So how do we check this one? All right, so we have the number 12,042. So take your digits, add 1 plus 2, don't need the 0, right? Plus 4 plus 2, so that's 3, 7, 8, 9. The sum of the digits is 9. Does 9 divide evenly by 3? And yes, it does. So guess what? The number 12,042 is divisible by 3. All right.
So nowhere have we figured out the two factors. We did figure out that one of the factors is 3. And what we did, we just took every digit and added it. 1 plus 2 plus 4 plus 2. Now, the reason why we didn't say plus 0, because if you add 0 to anything, it doesn't change the answer. And then we added those up, got 9. 9 is divisible by 3. So that means that this 12,042, I can divide by 3 and figure out the other factor.
Right, it is divisible by 3. So you're just looking at the sum of the digits, but make sure you sum them all up. Now, the divisibility rule for 9 is the exact same concept. Again, you're going to add up all the digits, only this time the sum of the digits have to be divisible by 9. So our previous number was this 12,042. Was it divisible by 9? And yes, it was, because 9 divided by 9 is 1. Well, what about this example? Well, 8 plus 2 plus 7 is 17. And can you divide 17 by 9 evenly? And the answer is no. And therefore, 9 is not a factor, or 827 is not divisible by 9. Okay, divisibility rules. So 3 or 9, sum of the digits divisible by 3, then 3 is a factor. Sum of the digits divisible by 9, then 9 is a factor. All right, try saying that 3 times fast. Okay, next concept, prime numbers. Prime numbers. What is a prime number? It's a natural number. Let's go back to lesson 1. Remember what natural numbers are? Okay, 1, 2, 3, 4, and 5 and up, the counting numbers. Okay.
Okay, so let's go over a little bit more in depth on natural numbers. And I know I've said this multiple times in class. When you get to higher math, your world will fall, the bottom will fall out. There are numbers before 0. There are numbers before 0. I know. Ever since kindergarten, we started with 0, 1, 2. But yes, there are numbers before 0. So because later on, there will be numbers before 0, we call the numbers that come after 0 natural in 6th and 7th grade, but then they become positive, which just means that they come after 1.
Okay. So a prime number is going to be greater than 1, but it has only 1 in itself as factors. Okay? So you cannot factor the number. So it's
okay, and again, prime numbers, the only way to get prime numbers is to multiply that number by 1. 2 is a prime number. The only way to get 2 is what? Use the multiplication. What's the only way? Yes, 1 times 2. That makes it a prime number. because it only has two factors. Prime numbers only have two factors.
Let's take a look. I've got a progression here. The number 2 is prime. The number 3 is prime. 4 would come next, but 4 is not prime, right? Because 2 times 2 is 4. See, we factored it. 5 is prime. 7 is prime. Of course, 6 is not, right? 8 is not. 9, 3 times 3, no. 10, 2 times 5, no. You get the idea? So then 11, 12 is not. 13. Can you think of the next prime number? What would come next after 13?
Okay, and so we'll just go in order. So the next number after 13 will be 14. So 1 times 14 gives you 14. But also 2 times 7 give you 14. So 14 is not a prime number because it has more than two factors. Then we'll go to 15. 1 times 15 will give you 15. Is there any other way we can get 15 using multiplication? Yes, 3 times 5 is 15. So that means 15 is not a prime number. Then I just continue, 16. I know 1 times 16 will give me 16. Is there any other way to multiply two numbers to get a product that equals 16? Yes, 8 times 2 is 16. So that means 16 is not a prime number. Then our next number is 17. I know 1 times 17 will give me 17. Is there another two numbers I can multiply to get a product of 17? No, 2 times what to give me 17? Nothing. 3 times what to give me 17? Nothing. 4 times what to give me 17? Nothing. 5 times what to give me 17? Nothing. The only way to get 17 is 1 times 17. So that's going to be our next number.
13. All right, so we're thinking of the next prime number after 13. Okay, and hopefully you're thinking 17. Okay, good. 18 prime, no. How about 19? Yeah, that's prime. See, this is the way you're going to think it through. 20, no. 21, no. 22, no. 23 would be next. And, at this point, you should pause the video. See if you can write the rest of the prime numbers leading up to 50, all right? So 50 is not prime, but what's the highest prime number just before 50? All right, so hopefully you thought then of 29 would be the next.
So yes, please take the time. Let's pause the video here. And then you go through the steps I just went through to find out your next prime number. So we got 29. So in your head, you should be thinking, what is my next number after 29? 30. Ask yourself how many different ways you can get 30. And then you just continue until you get up to 50. And then you write what the prime numbers are. And prime numbers, again, the only way you can get them is 1 times that number. So pause it, please.
Next one, 31, 37, 41, 43, and 47. And then it goes on from there, right? So those are the prime numbers all the way up to 50.
And he left out 49 because 2 can't go into 49. 3 times what to give me 49? 3 going to 4, 1, 3 going to 19. Nope, that'll leave a remainder. 4, 4 going to 4 one time. 4 going to 9 two times leaves a remainder. 5, when I look in the 1 spot, if it's divisible by 5, I have a 0 or a 5. So that's not the case. Oh, but 7 times 7 is 49. So he's right. 49 is not a prime number. Good job.
Well, what do you call a number if it's not a prime number? What do you call a number that's not a prime number? All right, so a number that's not a prime number is a composite number. Composite. And you can see we have a couple examples here of composite numbers. Because what is a 27? How about a 3 times 9? See? It's not prime, it's composite. Be careful with 34, right? 2 times 17 is 34. And that is a composite number, not a prime number. Okay?
And remember, composite just means that it has more than two factors. There's more than one way to get that number. Okay, so I definitely hope you enjoyed the lesson. I definitely enjoyed the lesson. Um, and remember, our objective was that we will be able to find prime numbers, and also, let me turn off this volume. I do apologize. And also be able to find the visibility of numbers. And we've done exactly that. We just have to remember our rules for 2. And what was our rules for 2? The number has to, in the ones place value, has to have a 0, 2, 4, 6, or an 8. And what was our divisibility rule for 5? Yes, in the ones place, it has to have a 0 or a 5. What was our divisibility rule for 10? Yes, in the ones place, has to be a 0. Okay, and remember, for 3 and 9, we add up the digits. So if I had 123, I would add 1 plus 2 plus 3, which will give me 6. 3, 4, 5, 6. Is 6 divided by 3? Yes. So that means that I can divide 123 by 3. Now, is 6 divided by 9 evenly? No. So that means I cannot divide 123 by 9 evenly. Okay? So I hope you enjoyed this video. I really enjoyed reaching out to you, going over prime numbers with you. I know it's a review, but again, this is one of those lessons that we got back at the beginning of the year. This is now toward the end of the year. And we've learned so much in between that sometimes we need that refresher. If you like this video, please like the video right below you. And please subscribe to Robert R. Church 4th grade channel so that when new lessons are posted, you'll get a notification so you can come back and learn with us. Okay, until next time, thank you.